Welcome to our magazine show 5G Campus Mag. My name is Jennifer Sarah Boone and it is my great pleasure to lead you through today's show. We will be talking to experts from industry and research about the challenges and opportunities that 5G offers for companies and what is already possible with 5G in industry and how the path to 5G in production can succeed. We have as guests today Ericsson. 5G is transforming business worldwide. Ericsson, as technology partner of Fraunhofer IPT, is bringing their 5G to the shop floor to enable the networked adaptive production. Fraunhofer Institute for Production Technology, IPT, who have established the 5G Industry Campus Europe, Europe's largest 5G research infrastructure, and thus show what is already possible with 5G in industry. Atlas Copco, who is a world leader in compressor technology, which is being produced in Antwerpen. Institute for Industrial Management, FIR. As the leading institute for the cluster smart logistics, they show today's possibilities and future's potential of industrial intralogistics. Laboratory for Machine Tools and Production Engineering of RWTH Aachen University, WZL, with a professorship Production Metrology and Quality Management and Manufacturing Technology. The mobile communication supplier Ericsson is already integrating and installing 5G networks in existing production halls. Bart Mellatz, who we've invited today, works at Ericsson and is a technical partner at the 5G Industry Campus Europe of the Fraunhofer IPT. Bart, it's great to have you here. Thank you for joining us. What makes 5G unique and better than any other wireless technology?
Well, let me start with wireless technology. That brings up a good point. Flexibility. Production lines need to be flexible so we can move equipment around. Then 5G uses spectrum that is licensed, ensuring that we have ultra reliable communication without too many interference while transmitting the data. Another aspect is mobility. We are using standardized handover procedures, ensuring that all the connected equipment on the shop floor can transmit its data regardless of its position and movement across the production facilities. All that, we're talking about coverage. Coverage is an important thing because we cover areas using a more efficient spectrum than other technologies and therefore reducing the need for equipment and saving energy. I think those are the main differentiators that make 5G a better technology compared to others.
We are right now in the largest 5G research infrastructure in Europe, and Ericsson is the supplier. Can you describe the 5G infrastructure in a little more detail?
I will definitely try, Jennifer. Well, we as Ericsson have been working together with Fraunhofer IPT for quite some years. And because of that and the good input we received from Fraunhofer IPT when coming up with this request to provide a network, we had a good idea of what we needed to provide. And one of the key aspects was modularity. We needed to assure that the network is easily extendable, yet keeping control over the network. That we did by using a so-called T6 deployment, which is a full on-prem deployment of a 5G network. And then we can add, as needed, so-called T3 deployments, offering a new set of radio access and a local breakout. This local breakout, by the way, is very important as that offers the connection between the 5G network and the existing production IT. By doing all this, we were able to create a setup by having a 5G non-standalone, a 5G standalone core, as well as an indoor and outdoor coverage. The radio network is running on the German industry band called N78, and we are able to use the full 100 megahertz of bandwidth.
Well, thank you so much, Bart, for kicking off our magazine show today.
Thank you.
We've now learned quite a lot about the benefits of 5G in industry and about the 5G network here at the 5G Industry Campus Europe in Aachen. And now I have Nils König with me. He's the coordinator of the 5G Industry Campus. Niels, we have here 7,000 square meters of indoor network and 1 square kilometer of outdoor network. That's a huge area. What are you testing here?
Yeah, as you already said, so the 5G Industry Campus Europe is the largest industrial 5G research infrastructure in Europe. And it's one of the model regions of the German government. And we receive funding from the Federal Ministry of Transport and Digital Infrastructures, which we are very grateful for. So we are able to test in this infrastructure multiple applications ranging from sensors, wireless sensors for process monitoring, mobile robotics, logistics, and also cross-site production chains. And furthermore, we integrated an edge cloud computing system into the 5G network in order to really boost up the potentials of 5G, because you need short reaction times, obviously, with the latency. And that's where the edge cloud is really attractive for.
It sounds very interesting, but what exactly does that mean? How can individual processes be monitored with 5G sensor technology, and what are the advantages?
Yeah. Well, look, so companies are always striving to optimize their processes for cost, quality, and time, and always striving to push their process to the physical limits. In order to reach that, and in order to safeguard the process, they need to monitor the process, measure multiple physical quantities like vibration, temperature, stress. And one of these applications is also the monitoring of the tool condition. So, for example, these kind of tools are used as a consumable, so it's a cost factor for the companies. And the way of monitoring this will be shown in one of the applications here. And it allows us to make use of the tool as long as possible. And it's, of course, an economical factor.
Next to me, I now have Sarah Schmidt, also a research fellow at the Fraunhofer IPT. Sarah, it's great to have you here.
Thank you.
What other options are there for monitoring complex process conditions?
Well, Jenny, one option that we are currently developing is the so-called 5G multi-sensor platform. It's one single platform with which you can monitor different physical quantities simultaneously in a process. So according to the application, you can choose for different and multiple sensors. For example, for this demonstrator and use case here, we would like to monitor vibration and temperature of a blisk during a 5-axis milling process. And as you can see, those blades here are really thin. So during the milling process, they start to vibrate, and this leads then to defects on the surface. To optimize the process, we would like to monitor vibration so that we are then able to adapt, for example, the spindle speed of the milling tool. And also, we would like to monitor temperature, since it gives us an idea about the strain that happens in the material. As I said, 5-axis milling process, so you can imagine some wireless sensors are not possible to place somewhere in this process. Therefore, we have the 5G multi-sensor platform, a wireless platform that you can place very close to the process or even on the workpiece itself. It has IP60A industrial grade, what means that you can use it in an industrial environment. And of course, this box here is very large, but will be a lot smaller and compact in future. So inside the box, we have a smart sensor platform, so some electronics for analytics and pre-processing. We have a 5G gateway based on a Quectel module. We have some battery packs for power supply, a time synchronization modem, and we have some internal sensors, a temperature and the gyroscope for internal diagnostics. So what happens here? We have a vibration and a temperature sensor that you can also see in this plot here. They are visualized. And they are constantly sending data via the multi-sensor platform into our 5G network, back to the shop floor LAN, into the industrial PC, here for monitoring and visualization purpose. So I can show you when I touch, for example, here this temperature sensor, then you can see, because I have very cold hands right now, it goes directly down. And also when I try to hit here the vibration sensor, you can directly see the peaks in the plot. And according to those peaks and to the temperature, we can then in real time react on the process, so control the process.
Well, it sounds pretty impressive. Thank you very much, Sarah.
Thank you.
Wow, that sounds extremely future-oriented, but also like a vision that is still pretty far off. 5G is not yet a topic with very many manufacturing companies. But now I'm very happy to have Andreas Thülich with me in the studio. Andreas works at the Ericsson Eurolab in Herzogenrath. Andreas, welcome. Thank you for being here.
Thank you for the invite. Glad to be here.
Can you let me know what opportunities companies in Germany have to work with a 5G network?
Allow me to say that 5G is for real. It's here and now. And the 5G Industry Campus Europe is a great example of what is possible with today's 5G products. You have seen all the exciting live use cases here. And they put really high demands when it comes to performance and reliability on wireless networks. Therefore, the availability of suitable spectrum is key. Spectrum is, so to say, the fuel of a high-performing network. And the good news are, there's a lot of spectrum available for 5G worldwide, which is usually accessible via the mobile network operators. In addition, some countries have dedicated networks for local installations, like in Germany. So you can choose either or why don't you combine them and aggregate them and use both? Now, as we've answered the spectrum question positively, how does a network look like? Who owns it? Who operates it? If you look at it on the highest possible level, you can deploy a 5G network for industries as part of a public network, as simple as just adding an indoor radio unit to your factory. Or, on the other end, to deploy completely isolated, fully self-contained. Depending on your needs for performance, your needs for isolation, depending on your ambition to operate the network on your own, and depending on your CapEx investment model, you can choose any of the deployment models in between those two extremes.
Well, thank you so much, Andreas, for your time today.
Thank you.
This sounds like a huge challenge for companies and a lot of preparation. So the question arises, is there the possibility for companies to inform themselves beforehand and get support for the implementation of a 5G network? The Fraunhofer IPT has developed the 5G audit for that purpose. Sarah, what is that all about?
Yes, the 5G audit is one offer from us for companies that would like to get in touch with 5G technology. Many companies are right now interested in 5G technology, but they are still very reserved to get fully into this topic. On the other hand, we have companies that already want to implement their own private networks for their own production site. So to cover this large range of where companies are at the moment, we developed the 5G audit in a modular approach, 5 steps to 5G, 5 modules. And with those modules, we would like to support companies to use 5G in the best way for themselves. The first module in our offer is the Experiments Day. It's one day at our campus site here at 5G Industry Campus with expert talks, discussions, with a tour around the campus site, hands-on demonstrators on the shop floor, and also a workshop in the end to start connecting 5G and own visions. And it's very important not only to understand 5G in theory, but especially in practice and practical use. And that's why we developed the 5G demonstrators. A next step, beside understanding the usability of 5G for industry, is also to go and think further about own applications, about own use cases. And that's exactly the aim of the workshop.
And what are the next steps after the workshop?
Well, the Experience Day is just the first module, as I said, out of 4 modules. After the workshop, it's a matter of identifying own use cases of the company itself, of their own production. And that's going to happen in a bilateral relationship where we are also going to evaluate afterwards the identified use cases concerning their economical potential. And the next step after that would be, as you can also see here on the slide, Module 4 and 5. That's for companies who then would like to implement their own 5G network. In the first step, we help them to define a concrete implementation strategy for 5G. And in the end, we also support them by deploying the 5G network on their own production site and also to help them implement 5G demonstrators and use cases on their production site. So as you can see, the 5G audit really tries to touch companies at every stage where they are right at the moment. And we try to individually support the companies right at this point.
Well, thank you so much, Sarah.
Welcome.
Atlas Copco will show us what the realization of a 5G network can look like. They've recently installed a private 5G network in their shop floor. Mr. Bavo Tielemans, thank you for being here today. You are the team leader of Smart Manufacturing. What challenges did you face in planning and integrating 5G?
Okay, so the first challenge we faced was getting permission to use bandwidth or to use spectrum that is available. For this, we teamed up with a telco provider who gave us permission to use part of their spectrum that could be used on our site and to deploy our own network. The second challenge we faced was when deploying. Setting up a private network is completely different from deploying, let's say, a corporate Wi-Fi network or a corporate network. So there was also a very steep learning curve for our own IT people and all the other people involved in installing the network on site.
And what exactly do you use 5G for? Are you already using 5G AGVs in production to transport components?
Yes and no. The first thing we really did with the private network is to put a camera on top of the AGV. This camera is streaming video, and it's really useful to get an idea of what is happening on the shop floor. Also, the playback function comes in really handy when, for example, a blockage happened or there was a collision in the shop. This really helps to detect what went wrong and solve the problems faster. Then we also switched over the signals coming from and going to the AGV. So they are now also transferred over the private network, and we notice increased reliability when compared to the Wi-Fi network. A completely different use case we have is energy consumption monitoring. So we developed some monitoring or measuring devices that can really measure the power consumption of a local asset like a machine or a robot. This really gives us insights in what is happening in the machine and also shows us potential for power saving.
What would still have to happen for 5G to be usable in the future in daily routines?
I think there the ecosystem really needs to grow and mature. If you look today on the market, there's not too many devices that are on an industrial level and are also compatible with a 5G standalone network. So a lot more devices need to become available for the companies to be used in different use cases.
Well, thank you so much, Bavo, for taking the time today. The industrial manufacturing and assembly of components with 5G in a daily routine is still a vision. However, Professor Robert Schmidt, professor at the Laboratory for Machine Tools and Production Engineering, WZL, at RWTH Aachen University, and member of the board of directors of Fraunhofer IPT and WZL, and Guido Hüttemann, head of the chair of Production Metrology and Quality Management, who are connected live, will show us how it could soon be realized and applied in the production halls of companies. Guido, you are testing the mobilization of resources and products in a 5G network using industrial robots at the 5G Industry Campus Europe. How exactly can I imagine that?
To increase flexibility in industrial assembly requires the mobilization of all resources that are used in assembly, especially when producing large products such as machine tools, trucks, maritime or aerospace products. It makes a lot of sense to move the machinery, in our case mobile industrial robots, to the work instead of the other way around. To do so requires means for those robots to navigate freely throughout the factory, to autonomously find the product, see where they are, where the robot is in space towards the product, and then come to a conclusion onto what to do as a next task and how to execute it. This requires processing a lot of 2D and 3D sensor information. It can be obtained from cameras or from LiDAR sensors on those platforms. However, processing this amount of data takes quite a bit of computational power, thus prompting the use for edge control systems. To wirelessly control a mobile robot, however, requires short latency and quite a bit of data rate. 5G, for us, enables us to do just that. Data rates of up to 20 gigabit per second and latency down to 1 millisecond allow the remote control of industrial robots and thereby contributes to flexibilized industrial assembly.
Well, thank you very much, Guido. Professor Robert Schmidt, what could the production of tomorrow look like and what advantages will it bring?
Future production systems will need to respond to requirements like resilience rather than simply incorporating old school terms like capability that were defined by quality management during the end of the last century. We will recognize that these systems will move forward from rule-based systems to goal-based systems. This marks a kind of a paradigm shift. The paradigm is that we move onward to the traditional synchronous production systems that are characterized by a continuous yet fixed material flow. Some of these enabling technologies that we need to incorporate is 5G communication, it's artificial intelligence, it's ubiquitous computing. And they will mark the responsiveness towards a versatile, a volatile, yet reliable production systems. We call this automation of automation. And this will lead us into a new future of production systems.
Well, thank you so much to the both of you. How the mobilization of goods with 5G can look like in the future, Professor Robert Schmidt and Guido just demonstrated. But what does a detailed solution look like? Well, to answer this question, Jacques Englander has joined us. He is a research associate at FIR in the Information Management Department. Jacques, welcome. What can a modern intralogistic solution in the field of Industry 4.0 look like?
AGVs are used in a variety of ways in industrial and logistic environments. This offers, for example, the opportunity to reconfigure the flow of products and components between machines seamlessly and therefore increases the degree of automation and flexibility. This flexibility comes along with several other benefits. For example, the shorter lead times, the better link between supply and demand, accelerating new product introduction, and last but not least, simplifying customizing products. But to exploit this potential and to make sure that the surrounding and environments of those AGVs are safe, of course, you have to make these intersections and environments safe. This, for example, is the reason why often these AGVs drives with a lesser speed in, for example, warehouses to be prepared that in case of an intersection and a human occurs, this AGV stops. But while equipping those intersections with sensors like this, it's a laser sensor, a laser scanner, the laser sensors detect that I'm in the surrounding area and therefore stops. But once I'm out of this area, the AGV receives the information via 5G technologies and therefore starts again his route. So again, we see that the flexibility within companies can be highly increased and therefore at the overall company and environments.
Now we've talked so much about possible 5G applications, also about those here at the 5G Industry Campus Europe. A huge amount of data is being sent and processed everywhere. But what exactly is happening with the data and where exactly is it being processed? Well, I'd like to hand the question on to Pierre Kehl. He's a research fellow at the Fraunhofer IPT, and I'm sure you can tell us a bit more about it.
Yes, thank you. So the 5G network is only a communication infrastructure to bring devices together, for example, machines and sensors. What is actually missing is the computing resource itself. And there, the edge cloud system is closing the gap between small devices near the machine and big public cloud systems with kind of immense computing resources, but being very far away from the process. So the edge cloud system is characterized by the fact that we bring computing resources close to the place where data is being generated and needed. In concrete terms, this means that small standalone data centers are installed in every production hall and therefore meeting industry requirements and offering a lot of computing resources.
And what are the advantages of the local systems?
So there are several advantages. First of all, security. So all the data is analyzed and stored locally here in the shop floor. So no ingoing or outgoing traffic. Then the real-time capability. You can install the edge cloud system in a way that real-time applications can be hosted. And since the surrounding network is under your control, you can use, for example, 5G or time-sensitive networking to have a real-time communication between the field devices and the cloud. The third point is scalability. You have all the nodes in your shop floor, so you scale it up. And of course, you can also scale up the hardware nodes corresponding to the needs of the applications and the amount of applications. If we have all these advantages together, then we can see that the edge cloud system is not only suitable for the industry, but is an active part in the production and can have real-time communication with all the devices, for example, in closed-loop applications.
Well, thank you so much, Pierre.
Pleasure.
We received many questions about 5G via social media, via email, via the website in the run-up to our magazine show, so that we at least wanted to try to answer a couple of them. But let's start with a question for you. Our viewers wanted to know, many say 6G is already on the rise. Shouldn't we therefore rather wait for 6G? Very interesting question.
Yeah, thanks for that question. I would recommend not to wait. 5G already offers a lot of opportunities to be used in industry, and it typically takes around 10 years for a new G to become commercially available. So why not start with 5G, have everything in place, and then do a natural migration to 6G?
Oh, thank you. Yeah, so that's the question. Do you really want to wait 10 years? So next up, Niels, I would like to ask you, or ask one of your questions. Is the integration of 5G also suitable for small and medium-sized companies, or is it only possible for large companies? Can SMEs afford something like this?
Oh, that's a tough question. So technically, there's no limitation regarding the size of the company. So 5G works for small and for large companies in the same way, but I see the point that it has to be economically feasible. And of course, SMEs do not have the resources like large companies. So I would say in the long run, there might be operator models, for example, for industry parks. So that will be a campus network for a complete industry park. And the companies then could share the costs and also the resources. That would be one option for that. But of course, there's options like slicing, which comes from mobile network operators. Mm-hmm. So we will see what the future brings here.
Oh, thank you so much. So we have time for one more question. And one of the questions that came up is, now there are also companies that do not want to use 5G themselves in their machine halls, but also want to produce and test 5G capable machines. Are there also possibilities or test environments for these companies? Sarah, can you answer that?
Yes, sure. Of course, I cannot speak for all test beds, but for example, for 5G Industry Campus, we have a whole 5G network here. We have fully equipped machine halls with machines from different vendors. Mm-hmm. And the aim for 5G Industry Campus and also for Fraunhofer is to cooperate with the company to do common research on 5G. So if some companies would like to test some 5G-enabled machines or 5G devices or their own use cases here, then they are really welcome to get in contact with us, and we would like to support them.
Well, thank you so much, Sarah. Thank you to both of you, of course, as well. And thank you for your questions. Unfortunately, we can't answer all of them right now, but please do not hesitate to reach out via social media, via email, via the website, and just keep on shooting with your questions. Thank you very much. 5G is and remains an interesting theme for the manufacturing industry. What could the future look like with 5G in a couple of years? Well, our partners at the 5G Industry Campus Europe just showed us. If you would like to exchange ideas with the consortium, you can contact them via LinkedIn or the webpage. And additionally, you can talk directly with Niels König after the magazine show via the Teams link that you'll find pasted below, and ask any question that we couldn't address during the show. We are looking forward to exchanging our ideas with you and to hearing what you have to say. Thank you.